And hello, I think we are live. Welcome to another Race 3D live stream. As always, my name is Nick. I'm in the demo studio. I'm joined by Buzz Baldwin from 3D Printlife. How you doing, Buzz?
Great. How you doing?
I'm
Good to
doing
be here.
fantastic. Pleasure to have you. You're with 3D Printlife. You please give me a rundown on just what that is, how we work with you, what you guys do, get me up to speed.
Yeah, no, absolutely. So we're a filament manufacturer. We have our own line of materials that are geared towards the sustainability, eco-friendly vein. We do carry some filaments from some other manufacturers. We like to think of it as sort of a curated collection from a few specific providers, mainly from Europe at the moment. We've got some stuff from Formatura and Filamentive, stuff that's harder to get here in the States. And we're a reseller of 3D printers, including, of course, the Raise 3D line, which we are huge fans of because of the quality and everything else involved. And that is us in a super nutshell.
Fantastic. So you mentioned like sustainability. What are the things that you're focusing in on the specific materials? What are the highlights of your guys' specific line?
So where we really have market separation are in a couple of areas. We've got some materials that are sort of unique blends of bioplastics like PLAs, PHAs, and other bioplastics that give different material properties while still being in that sort of PLA base. So we've got PLAs with algae in them. We've got some that are meant to mimic things like nylon or ABS, but still fall under that sort of biodegradable umbrella. Even a semi-flexible and tough PLAs that are in that vein. And then we have some IP in bioadditive technology, which we've combined with more standard materials outside of the PLA range, like PETG and ABS, soon to be hopefully ASA, polypropylene, that essentially the bioadditive technology we're using essentially provides a food source for bacteria once these materials end up in the waste stream. So it doesn't alter the material characteristics. So your PETG parts, your ABS parts will still perform that way. They won't start to degrade on your countertop or in your end use parts, whether it's in a machine or whatever sort of your application is. Really, once they get into the waste stream, that's where you see the benefit of the bioadditive component that allows bacteria to consume it and eventually degrade it over time. Not the same way PLA does, but still massive upgrade in shortening the lifespan of a part that's going to end up in the waste stream.
What's that process like for your material versus any other standard PLA or just whatever is more commonly off the shelf? What makes yours unique in that waste stream breakdown?
Great question. And so for standard PLAs, the standard for PLA is the testing involved. It's ASTM D6400. This governs biodegradability of plastics. And so PLA meets this standard. All that means is that it's going to degrade by 60% in 180 days in a commercial compost environment. Now, some of our blends might have some bioplastics that might go a little faster, in terms of degradation. Our algae-based PLA, the algae content is already organic to begin with, so we don't have to worry about that percentage of the material degrading at all. We're just sort of concerned about the base PLA material. But they've all been there's a lot of the materials we have in that vein are unique to us, and they're sort of Frankenstein blends that might have more or less degradability, but still keep it under that sort of PLA umbrella. When we're talking about things that contain our bioadditive component, and actually, if you want to do a screen share, I can show some examples on our site that'll give you a little bit of a guide here.
The screen share guide will be perfect.
Okay, all right, great. So here, let me just we'll go to our BioPETG. So this is a standard PETG material that's been enhanced with our bioadditive. And this conforms to a different set of ASTM standards. D5338 and 5511 are really just variations of composting facilities, landfill facilities that are active, or landfill to energy facilities that, and I can explain that a little bit. So an active landfill is not just an entombed landfill where a banana peel might take decades to degrade. This environment is truly one of the nastiest environments on Earth. You have a high bacteria content that is designed to consume material that goes into the landfill and convert the carbon in those base materials into CO2 and create landfill gases like CO2 and methane. And the way landfill to energy facilities work is they collect that methane and either collect it for storage to use later, or they quickly refine it and burn it to create electricity, hence landfill to energy. Now, the way our plastics work, the way the filaments work, is once they enter into this environment, into this waste stream, the bacteria in that environment begins to consume the plastic. And it's really our bioadditive that just provides a constant food source for the organisms in these facilities. And here we have a nice comparison showing standard, petroleum-based plastics like ABS or PETG in the red line here, and CO2 production based on those materials. And then the green line would be steady CO2 production with a plastic that's containing our bioadditive. The way the testing works, it looks interesting here. You see some CO2 production initially from the base plastic. What's really happening there in these testing facilities, you're using vats that are sort of smaller and self-contained, and the bacteria in the vat will come and try to consume an ABS, a PETG. And what happens is they try to consume it. I sort of equate it to you see a great white shark trying to take a bite out of a boat. They're really testing it to see if it's a food source. But what happens during the testing, when the bacteria tries to consume that part, it produces an electrical charge. That essentially is like ringing the dinner bell for all the other bacteria in the vat. And they end up swarming over to that location. They can't consume the plastic part, and they end up cannibalizing each other. And that's where we actually see this CO2 production in the standard plastic test, is the bacteria consuming each other. And then after 2 to 3 weeks, you start to see that CO2 production drop off a cliff. With the bioadditive component in the base material, you see this steady production of CO2. One of the questions we get asked a lot is, how long is it going to take my parts to degrade? And it's a really tough question to answer. Every facility is different. The bacteria contents are different, even within a facility, within a vat of, within this sort of leachate bacteria system. Bacteria might be more concentrated in one part of the landfill than another. But when we extrapolate the data from our testing, the standard ABS or PETG parts might take 800 to 1,000 years to degrade, or ours might have taken, 15 to 20 years or less to degrade. We don't really try to claim any of that information. It's hard to claim without, you can only actually claim the official data unless you run the test for that amount of time, which is not really feasible. So we're just, showing how it performs during the testing period. But obviously, in addition to the variance inside each facility, you've got the variance of every part that goes into it. So what's the mass, what's the mass, the size, the infill percentage, all that, is a massive variable in how long it's going to take your part to degrade. The key thing to remember is that once it gets into this facility, you do have that eco benefit because of the bioadditive component in our filaments, but you don't lose mechanical strength or lose lifespan of your part when it's being used in the real world. It has to get into this really high bacteria-rich environment in order for your parts to start to degrade. If I always say that, if your part starts degrading on your kitchen countertop, you've got much bigger problems than your part losing integrity, for sure.
Something else in your house, you're having the bacteria that's breaking down these parts, because it is a specific type of bacteria that's meant to feed on the extra elements in that material and then break it down. The breaking down shouldn't happen until it's in the waste environment, essentially.
Exactly. And so really we get the benefits of the strength, all the mechanical properties of whatever base material we've combined the additive with, and you don't lose that. So you can feel secure that your parts are going to work long term, but things like, failed prints, support material, or when your part reaches end of life, you've got that extra peace of mind that once it gets into the waste stream, you do have that added eco benefit, and your part's not going to sit there for hundreds of years, depending on the facility it ends up in. We are all sort of at the mercy of our local municipality in terms of where our trash goes, but there are thousands of active landfill to energy facilities in the U.S. So chances are better that they're going to end up in, there than sort of a capped or entombed landfill.
Yeah.
So that's sort of how the bioadditive filaments work. So that really covers our BioPET-G, our EnviroABS, and then some future materials down the road. We're hoping to do a polypropylene and even a special round of our BioPET-G and a polypropylene to work with prosthetic check sockets for that industry, where you've got check sockets are basically printed for a patient to wear and test out the fit of a prosthetic socket for a few weeks before they end up getting a definitive or permanent socket. So there's a planned obsolescence there of a part that's going to last a few weeks. So having an eco benefit there is really beneficial. And so that covers really sort of that range of plastics. The rest are really more, again, sort of in that PLA blend range. I mentioned the algae material, so I'm happy to jump into that one.
Yeah, please do. Just whenever, of course.
So so this material is it's PLA. It was originally developed by Algix years ago, and they got out of the 3D print space, and we asked us to take over their lines for them. And so this is a PLA with a little bit of a bioplastic modifier to help sort of stabilize the material and make it easier to 3D print. But we've taken this nuisance algae that's been removed from the environment, from waterways, ponds and waterways, where it's causing damage to marine life or aquatic life, and so it's being removed from there using sort of a skimming process and these micro air bubbles that actually reintroduce some oxygen back into the system. So before this filament even gets on your printer, there's an eco benefit happening, which is great. But we've also got this really cool, these are standard PLA colors, and we end up getting this really nice color palette that's very earthy. The material itself has a feel of like sandstone or wood, even mimics bone maybe a little bit, although certainly not as strong. But this is the natural color here, without any color added, and there's obviously going to be a lot of variance. I mean, you can see it's a natural material here. You can see variance within layer lines, not just throughout sort of the length of the spool. You see variance in color there that's really unique to this material. I really love it. It's one of our more popular materials for sure. We reformulated it just to make it more stable for 3D print and just sort of remove some of the brittleness of it and increase its lifespan. But it's a great material. I love it. It's really popular. Then I'll just kind of bounce around. We'll do the tour today.
Here, so actually, one second. Hate to interrupt. If you want to get your screen share up so you'll have the direct one, I've been kind of supplementing you for the time being. But it would work a lot better with yours going.
Okay. Am I going for you right now?
Not yet. I think you need to reactivate it from the bottom.
All right. Okay. Hang on a second here. Oh, get out of there. Oh, technical difficult. Oh, there we go.
Yeah, I know.
There. Right. And we're back.
Okay. Yeah, there we go. So now you're in control. Go ahead.
Okay. All right. Great. So, so if you couldn't see any of the stuff I was doing before,
we could. I was doing my best to keep up, but as we're going to jump around the side, I don't want to be chasing you. So.
Oh no, that's fine. That's great. Okay, cool. So our replay. This is a recycled PLA filament. One of the questions we get asked a lot, being a manufacturer that's focused on sustainability, we get a lot of offers from customers and just the general public to have them send us their scrap filament for recycling. We get a lot of offers to get, sent a ton of PLA. I get, multiple emails a day on this. And I would love to find a way to take it in. There's really just no feasible way to do it because we just don't know what we're actually getting when it comes in. People could tell us they're sending us PLA, but there could be, ABS, PET-G hips, who knows what's actually in it. And if you try to sort of grind that up and recycle it and extrude it, you end up with a really nasty polymer that doesn't perform well or extrude well, and it's just not worth the headache, unfortunately. So what we've done here is we've created a recycled PLA that is strictly made upcycled from production scrap. So any PLA we're making that is out of spec, when we're changing diameters or changing colors, this is what ends up sourcing this material. All we've done to it to modify it is add some black to it to stabilize the color, because as you'd imagine, it's kind of a gnarly color when you just sort of mix everything together.
Yeah, I'd imagine.
But it's really stable. It prints really well, and it's priced pretty reasonably. We only have it in the one color and one diameter at the moment for 175. We're working on doing a 285 line. There's just not nearly as much 285 usage in the US as 175. So we launched it at this diameter. So that's Replay. And then let's see here. Our Pro PLA, it's PLA with a little bit of a bioplastic modifier to increase strength, increase pliability and lifespan a little bit, better impact strength. Nothing, not a major, I wouldn't call it a tough PLA or anything. It's just a, impact modified PLA. Now our Pla Fab, on the other hand, is a different story. So this is really a tough PLA in our minds. This material is, here, I can give you some indicators on strength here. So this material, it's a PHA blend, not unique to the 3D print space, but our PHA source is, I think, unique in the US. But it adds a lot of impact strength, a lot of pliability, massive upgrade in shelf life. Some universities have used this exclusively, have left spools out on the shelf for 18 months and put it back on the printer, after it's been exposed, and it prints like it was just taken out of the box. So you don't see that sort of normal PLA degradation because of exposure, which is great. We have had some challenges for sure, like in supply chain, like everybody has over the past year, and sourcing the PHA has been difficult for us. And same with our Yoga Flex. This is a flexible, biodegradable material that is made from some kind of funky, it's a funky blend of materials, but it's a really nice, strong, semi-flexible material. It's really permissive to print with. It is just raw material has been scarce over the past year, but we're looking like we'll be able to get these back in play here over the next quarter. So I'm hoping by Q3, we'll have these back in stock. They're both really popular materials. And then really sort of the next two that are kind of unique to 3D Printlife would be Omni and Dura. These are, again, sort of Frankenstein bioplastic blends. Omni is really meant to be an ABS mimic. It's a PLA base with some other bioplastics involved that make it really rigid and strong like an ABS, but you still have that biodegradable component. So it falls under the same standard that PLA does. And Dura is a nylon mimic. So this material has a little more pliability to it and sort of mimics that, that look, that feel of nylon, where you can really sort of get some nice part twisting, but it'll really take a nice impact strength. A lot of drone guys are using this because it'll take an impact where it won't, because it's not rigid, it won't shatter, but also prints at a really low temp. It'll print at 175 to 195, which is a minor sustainability benefit. But you've got a lot of these materials that don't require a heated bed. And if you have printers, unlike obviously the Raise platform is pretty versatile in material compatibility, of course, but for other printers that don't have a heated bed, this really opens up sort of material options for you because they don't require a heated bed and will still perform great on a printer that doesn't have one. But even if you're using something like the Raise platform, one of the things that we factor into sustainability is quality of the hardware. So when you have features like, auto bed leveling, filament runout sensors, all these things that sort of go into reducing failed prints, that is another way to improve sustainability in 3D print because, obviously less failed parts means less wasted material, less energy consumed. It all sort of factors in under the same umbrella for us. So anything you can sort of do to whittle away the variables that can cause a failed print is going to improve sustainability from there. So, and from there, I think I can stop screen sharing. We can take a peek, get another look at you and your 3D printers over there. But that's the quick tour of the 3D Printlife lineup.
Fantastic. It was, thank you very much for one. I like the uniqueness that you have for your guys' specific materials, things like the Omni and the Dura, how it is intentionally specifically designed from the get-go to work for lower heats, lower temperatures, just using less energy overall from essentially start to finish, where the materials come from, how they're being printed, how they're being, kind of degraded afterwards. The entire life cycle of the material from start to finish is always being kind of consciously brought around and prioritized for what you guys are doing for your materials. And I think that's fantastic.
No, thank you. And of course, I sort of forgot to mention the obvious that you could see there in the images was the spooling we use is cardboard spooling, so we're not using plastics there, which actually can come in handy because some of the plastic spools, if they're being heated to a high temp, can warp a little bit.
Yeah.
They're much less likely to crack in shipping as well.
Yeah, I've had a few spools of my own because we do drying nylons and whatnot where they're drying at too high temperature. I have warped the spools themselves in filament dryer, so just keeping the cardboard works with that too. Are those spools fully recyclable? Because I think it is the cardboard sides in like a metal core, but that
it is, yeah. So there's metal end caps. I actually have one here, right? So here's a blank spool. So these are just loose metal end caps. They're made of tin that they use to assemble the entire spool together in one shot. Technically, I mean, the whole thing could go in a recycling bin, but you could take a few, like 30 seconds with a screwdriver and pry it apart and get going. This thing is really strong though. It's really hard to get apart, so we don't lose any integrity of the spooling with the outward pressure that happens when you're winding the filament on. We are looking to migrate to a fully glued spool. We've got a high temp glue that'll work. We're just sort of dialing that in just to sort of remove the end cap. The end caps themselves they're not a pain or anything. I actually enjoy them. They're strong, they're really durable, but it's an added sort of labor component. It's definitely more of an expense. And cardboard, everything's been going up in price over the past year. So anything we can do to sort of minimize that is going to be, we don't want to raise our prices on our filament because our spool components are getting more expensive. But one of the things I like about the metal end cap version though is even with filament on it, the flange can actually rotate. So if you end up cutting your filament in the wrong place, you can just rotate it to get to line up the holes. That's a minor benefit, but it's one I dig. Oh, I lost audio on you. I'm sure everything you're saying is brilliant though.
Yeah, of course.
There we go.
There we go. Say I'm back. Yeah, no, just every little detail like that, being able to rotate the spools. Like you said, small benefit, but it does factor in. I just saw you doing that, and I was like, I wish all of my spools did that, honestly. But
we'll lose that when we go to fully glued, but I think the benefit there will be better anyway, long term for everybody. I'm looking forward to making that change, but hopefully somewhere this in the next quarter or two we'll be able to pull that off. But either way, it's definitely more a sustainable option. And I mean, look. We're focused on sustainability with our own materials. We do carry materials that are, would not fall under that umbrella. We're not trying to be the morality police here. It's more about like, hey, if you want some more sustainable options, here they are. If you want to mimic some of these other materials that you might not be able to use on your, standard printer that doesn't have a heated bed or an enclosure, we've got some materials that'll work fine for you there. But just in general, I mean, even if you're printing in something in peak, chances are you're not going to be doing your test printing in peak. You might do some prototypes in PLA first anyway. So we always recommend doing something like that to not waste, that high-end material if you can. But either way, it's more about like presenting that option. It's like, hey, if you want a more sustainable option, here it is. If you want your standard materials, here they are as well. I mean, the whole point of 3D print is just removing limitations, giving more opportunity for, home users, innovators to create something on their own without using traditional fab that takes a lot of time and money to achieve. You can do so much with a 3D printer and the right material to sort of realize your vision.
Yeah. So working with things like Pro 2s, Pro 3s, it's all about the variety of materials you can use and expanding the options of what you can do with not only just, designing parts and manufacturing in general, but with these specific machines, things like Idea Maker, cloud, remote operation. A lot of things that we prioritize are just opening up those other options, including things like the Open Filament Program, partnering with you guys and other manufacturers just opening up the space, making it easier to work in and get more out of these machines, and make them greater than the sum of the parts, essentially. But
Exactly, and it should be that. And I love the open filament program. I mean, that, even that in itself, I mean, just, sort of a small nod to sustainability. I mean, just having the print profiles loaded already for you in that program, just again, just reduces sort of lead time of dialing in material. You just sort of, off to the races the moment you get the spool on the printer.
Yeah.
But definitely, I mean, look, we love the Raise 3D line. I'm dying to get a Pro 3 myself. I'm jealous every time we ship one out the door and I don't have one for myself. But I mean, that whole platform, I know it's been upgraded from the Pro 2, but that whole platform certainly does improve print quality, definitely reduces failure rate, which, from a sustainability standpoint is great, but just from, a functional high-end prosumer FDM 3D printer is fantastic.
Mm. Yeah. So I think we're about coming up on time, but did you have any kind of last things to wrap up on? Anything new coming out from 3D Printlife?
Yeah, we're actually, thank you for asking. We are working on a couple of new materials. One will be a PETG that's made from post-industrial recycled materials. So your plastic drinking bottles, right? So Arrowhead out there, Poland Spring out here, recycled bottles combined with our bio additive. So we get a recycled material coming in with the bioadditive component, so it's greener coming in and greener going out. Sourcing that material has been a bit of a challenge. You'd think it would be simple, but it's been a little challenging to get quality material in. And then another one that I'm really hoping to get launched in June or July is really a game changer for us, and I'm hoping for the industry as a whole. It's a filament made from a certified marine and home compostable material. First of its kind. I'm really excited to get it out on the market. We're still sort of working on completing some internal testing here. Everything right now looks really good. I'm not sure what the price point is going to be like yet, but to have a material that is truly home compostable or made from that material, home compostable, marine compostable, will be a game changer for us. Oh, can't hear you. There we go.
There we go. Availabilities of like where these things can be used. The kind of breaking down, being home compostable would be a huge one. And then, doing it in marine environments, it's just adding on to more sustainability, getting more things out there. So
we certainly don't recommend tossing in parts in the ocean.
Of course
let's be clear. But we do get a lot of requests from people that are working in the marine environment, whether it's about things like NOAA or people that are just like sort of scuba divers that are, making parts that could accidentally end up in the marine world. It's a great benefit there. But again, certified marine or home compostable, it'll be made from that material. Again, sort of the same factors apply though, as in terms of how long it'll take these parts to degrade. That'll all depend on the size and shape of and mass of the part once it's completed. But still, massive upgrade in technology as far as sustainable materials go in 3D print.
Yeah. So I'm looking forward to having that new material soon. Looking forward to a lot of new things you guys are coming out with. Again, we're always working on our new machines as well. We do have more things coming out for actually a lot bigger machines should be coming out. We'll be out at like TCT Rapid, a lot of the trade shows. So if you're there, come check us out. And then, on the website, we have a lot of information for our machines. Demo studio is always available. Just come in here. We can talk about the machines as well. We've got other live streams on the Pro 3 series, the E2. So if you guys want to check those out, I'd love to get extra views on those videos. So whatever we can do to get this going. But I think it's going to do it for us today, Buzz. Thank you very much for joining me.
No, thank you. Yeah, it was my pleasure. A lot of fun. Thank you.
Of course, it's great to have you. But I think that's going to do it for us today. We'll go ahead and wrap it up, and I will see everyone in the next stream.